Hello everyone, welcome to our statistics channel, Quality Statistics. In the last video, we discussed the general concept of measures of dispersion. And today we will discuss absolute measures of dispersion. The first part is absolute measure of dispersion and the second part is relative measures of dispersion. In the part of absolute measures of dispersion, we get first of absolute measure of dispersion is range analysis. Definition of range. Range is defined as the difference between the extreme values, that is the highest and the lowest values in the series. Thus, if a given variable x has n values arranged in ascending order, x1 less than equal to x2 less than equal to x3 less than equal to dot 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 less than equal to xn. Range is given by r equals to xn minus x1. Xn is the maximum value, x1 is the minimum value. Therefore, range is the difference between maximum value and minimum value. When the data are in the form of a grouped frequency distribution, then this technique is also applied in the form of group frequency distribution structure. When the data are in the form of a group frequency distribution, the range is the difference between the upper boundary of the highest class and the lower boundary of the lowest class. This is to some extent different. The pattern is same, but calculation is different. The first sum on range determine range for the values of x 11, 5, 7, 2, 15, 30, 35, 40. First, these are not arranged properly, and arranging the given data in ascending order, we get 2, 5, 7, 11, 15, 30, 35, 40. From this arrangement, we see that x mean equals to 2 and x max equal to 40. That is 2 is minimum value and 40 is the maximum value. Hence, range equals to r x max minus x mean, that is 40 minus 2 equal to 38. The answer is 38. Now, we mention a special thing that when class limits or intervals are given, then first we find class boundaries and then choose the upper class boundary and lower class boundary, and then we use the formula R equals to UCB LC minus LCB FC, where UCB LC means upper class boundary of the last class and LCB FC means lower class boundary of the first class. Now we present an example of grouped frequency distribution and finding range. Find range of the following distribution. This is a wedge distribution. 1000 wedges are measured 1000, that is 1000 to 10,000, 11,000 to 20,000 and so on, 41,000, 50,000. Number of laborers are measured in hundreds, that is 200, 500, 800, 1000 and 100. From the given distribution, first we arrange class boundaries of wedges and then proceed. Wedges 1 to 10, its class boundary will be 0.5 to 10.5. And wedges 11 to 20, class boundary will be 10.5 to 20.5. In this way, we get the last class boundary 40.5 to 50.5. And the laborers are this 2, 5, 8, 10, 1. Here LCB FC, lower class boundary of the first class, that is 0.5. This is the first class and this is lower class boundary. And upper class boundary of the last class, that is UCB LC 50.5, that is 50.5, and range equals to UCB LC minus LCB FC, that is 50.5 minus 0.5, and this becomes 50. Now we can say that range of this wedge distribution is R equals to 50, that is counted 50,000. These are two different problems. One is simple and second is group distribution problem. Though range is very simple, yet it has several limitations. And now we mention the limitations. Number 1, it does not depend on all observations. Number 2, it is influenced by extreme values. Number 3, it is also affected very much by sampling fluctuations. Number 4, it does not consider the variability of the observations around the central value, because the central value is not taken into account in calculating range. Number 5, it is not capable of mathematical manipulation. Now the concept of range, the discussion of concept of range is complete. This is all about today. Please keep watching our channel for new videos and new concepts. Thank you everybody for watching this video.